Geometric sequences. To find the general formula, we multiply the first term by the common ratio as many times as the number of desired terms. So in this case, we're going to multiply the a. Okay, example. We have 1 times 3 to get the second term, which equals 3. So in this case, the first term, do notice, is a 1. Or our equivalent in variable or letter format, a sub 1, an initial value of 1, times the r. Second example, 1 times 3 to get the third term, which equals 9, or our initial value, a sub 1, which in this case is 1, times, there's 2 of the 3's, right? So that would represent the r square. So in general, we have 1 times r times r times r, up to infinity if you choose to multiply by r's, to get the nth term, or a sub 1 times r to the power of n minus 1. So that is for our geometric sequences in this case. Once again, to find the general formula, we multiply the first term by the common ratio as many times as the number of desired terms. Okay, so once again, geometric sequence formula. We have a sub n equals a sub 1 times r to the power of n minus 1. In this case, a sub n is the nth value, the value that is needed for the nth term. A sub 1 is the initial value, or the first value. R is what we call the common ratio. And of course, n is the nth term. There we go. And let me just copy it over here on the right side. Arithmetic sequence formula, and just the formula, copying it all over. A sub n equals a sub 1, the first term, in other words, times r to the power of n minus 1. There it is. And let's list them once again. First term, 1, second term, 3, 9, 27, etc. That's what happens when we multiply by 3, right? In other words, 1 times 3 gives us 3, starting with the initial amount of 1. And then up next, 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, etc. Agreed? So let's find out whether we have a common ratio or not. So common ratio. Here we go. For this case, we have the 1 that we're looking at the first, but we're going to use the next term. So looking at the 1, you use the next term value, which is 3. 3 divided by 1, in other words. And that gives us 3. And now let's look at the next step by looking at the 3. If you look at the 3, now you're using the 9. So in other words, 9 divided by 3 will give you, in this case, 3. Let's go to the next step and look at the 9 if we choose to, etc. So you can keep doing this as many times as you wish to. But you can also sample around. So let's try sampling around instead. Looking at the 81 now. In this case, we're going to use 81 and 243. That's the next number, right? So 243 divided by 81 should also give us 3. Yeah, just as expected. By sampling, we verified that it also gives us a common ratio of 3. Let's go to the next one. So in this case, jump in one of those values. But still, once again, it's like sampling around. We have 729, and we're going to use 2187. 2187 divided by 729 will give us also 3. All right. So that means we found the common ratio of 3 in this case scenario. Agreed? Since we now know the common ratio, we can actually write the formula finally. What we want to realize is that we know the first term, right? So the first term. What is the first term in this case? Well, the first term is giving us the 1. So first term value, we can just say it's a 1. There we go, it's a 1. And likewise, we found the common ratio of 3, right? Okay, so that means we can write the final formula. So let me bring down our formula reference here. There we go, writing our final formula for this geometric sequence. Our a value, initial a value, is a 1, agreed. So let me get rid of that a. Our r, in this case, this is 3. And it's raised to the power of n minus 1. There it is. There is our final formula, which we can circle because it's our final answer, right? Here we are. And we are done finding our geometric sequence.